Hello, my name is Antonio Colani, and today I'm going to talk to you about reactive NPC systems using Chatgpt. So, what exactly is a reactive NPC system? Well, it's a system in a video game where non-playable characters respond dynamically to the actions and decisions of the player or other elements in the environment. The term reactive implies that the NPCs have the ability to react to stimulus or changes in the game world. Now let's talk about Chatgpt. Chatgpt is an AI chatbot trained with massive amounts of data that recreates human-like outputs such as text and images based on a user's prompt. We can use Chatgpt in our reactive system so that our NPCs generate dynamic and contextually appropriate dialogue based on in-game world events. So what are some benefits of using this technology? Well, first, it's adaptive behavior. Instead of relying on fixed dialogue trees like many games do nowadays, NPCs can change the behavior and responses based on environmental changes or player actions. This diversifies dialogue lines and reduces the likelihood of players encountering repetitive or scripted responses. This leads to our second point, which is emergent gameplay. Dynamic dialogue can provide unique and personalized storytelling. Every game session could have countless possibilities. The game narrative can evolve based on players' decisions, providing a more immersive and interactive experience. Generated dialogue can also be quite efficient at content creation, as developers can design algorithms to deliver large amounts of dialogue quickly. This is also quite useful for games that have expansive worlds and many characters. For this demo, I've used the OpenAI plugin for Unreal Engine 5. You can find the link in the description. Inside Unreal Engine 5, I set up a blueprints project with a first-person character template. Then, created a house environment inside a level and placed two characters that use a custom blueprint to create instructions or prompts depending on the situation. Afterwards, I send this instruction as an API request, and finally I display the API response on a widget. This environment is filled with interactive objects that the player can pick up and play with. In the current version of the game, NPCs don't have the ability to see us, so we can mess around with them. Using the AI perception component, our NPCs are able to detect moving objects in front of them. Whenever they see an object moving, they're able to take a predefined descriptions from the object's blueprint and use it to construct an instruction. Additionally, each character also has their own description, which allows us to showcase a distinct personality through their dialogue. In this case, our red NPC believes in ghosts, while our yellow character is somewhat of a skeptic. You might also notice that NPCs roam around the map. Whenever they see a moving object, they'll run towards it. For this, I've used a behavior tree that allows me to change states. Depending on the state, the character will proceed to play a certain action. Behavior trees can be quite useful for creating specific instructions based on a task, as well as to display additional reactions. Here, I'm using it to display the NPCs inspecting an object after seemingly moving on its own. Through some iterations, I've added some extra features, such as giving the NPCs memory of the object's location. Characters can remember the location of each object in the scene, and when they find an object that has been displaced out of sight, they will react accordingly. NPCs can also talk to one another and react to each other's reactions. Having your in-game characters showcase social interactions and relationships can add a great amount of depth and immersion to your game. Another great advantage of using Chatgpt is that it can generate responses in a wide range of languages, allowing for flexible content generation and translation. This can be useful when dealing with multilingual audiences. All we have to do is ask to get our desired output in a specific language inside of our instruction. How could we use this technology in real-life applications? Well, one idea is interactive art. We could incorporate AI-driven characters into interactive art installations, museum exhibits, or even interactive theater to create engaging and dynamic experiences for visitors. We could also use this technology for emergency response training procedures. By simulating realistic emergency scenarios with AI-driven characters acting out as real people, we could allow first responders to practice communication and decision-making skills in high-pressure situations. We could also create AI-driven companions for individuals with disabilities. These companions could assist with daily tasks and offer support in different contexts. Lastly, let's take a look at its limitations. It can be quite unpredictable. AI-generated dialogue can sometimes produce content that is unexpected or inappropriate. Ensuring the right control over generated content can be quite a challenge. We could also have quality issues. Dialogue that is generated may lack the creativity or the same emotional depth that human writers could bring to the table. Achieving high-quality, emotionally captivating dialogue is a challenge for AI systems. Finally, there are some concerns regarding the data that is being collected to train these models, and whether or not people have agreed to having their work sourced for this purpose. Furthermore, models may learn from biased or inappropriate information, potentially generating harmful responses. In conclusion, reactive systems with generative dialogue have a great potential as tools to enhance interactive environments, both virtually and in the real world. However, in its current state, this technology is not the most reliable for every situation. In the future, I'm expecting we see these AI models get better and better with more human-like responses and realistic interactions.